Good morning and Jai Hind children. I welcome you all in today's live class of chemistry. Children, as you know that in previous class I have discussed the book exercise, that is multiple choice question, very short answer questions and the short answer question. Is it? I hope that you understood and you have completed your work in your notebook. Now today I am going to discuss the next exercise of the book, that is long questions. Okay children, so please listen them carefully and understood all the answers of long question. The question number 1 is, explain the differences between an element and a compound and give examples. So children, you know that there are a number of differences in elements and compound. Like the first one, the elements, which is a substance that cannot be decomposed into simpler substances by any chemical means and is made up of only one kind of atoms. Okay, and such substances are called elements. Like example is hydrogen, oxygen, sodium, and all. These all are the example of elements. Whereas the compounds are the substance formed by the chemical combination of two or more elements, and these elements are in fixed proportion. So these substances are called compounds. Example, water, carbon dioxide, etc. So these all are the examples of compounds. Okay children? Now the second difference is that an element cannot be broken further. Okay, whereas a compound can be broken into its constituent elements by chemical reaction. Children, please remember that compound can be broken but by chemical reaction, not by any physical method. Okay, so this is the second difference, and the third difference is the elements. There are about 118 elements on the earth which are known, whereas the compounds are many more. They are innumerable compound around us. Okay, because the compounds are made up from the combination of different elements. So the different elements get combined in different proportion, in different ratios, and they form the number of new compounds. So the compounds are many more, whereas the elements are 180. Okay, so this is the first long question of your exercise. Now the second question is, explain the differences between the atoms and the molecules of an element. And can a molecule of an element be the same as its atoms? Give an example. So children, please remember that when we have explained in the chapter about the atoms. So the atoms is the smallest particle of an element, is it? That can take part in a chemical reaction, and it may or may not exist independently, because some of the atoms of elements existing independently and some are not existing independently. They are existing in combined form. Okay, whereas a molecule is the smallest particle of an element that can normally exist independently. Okay, so those molecules of the elements which exist independently, we will use the terms molecule, whereas the atom term can be used for those particles, the smallest particle of an element that can take part in chemical reaction. Is it? And the next part of the question is, can a molecule of an element be the same as its atom? So yes, the answer will be yes. A molecule of an element can be the same as its atom. That means its atoms exist independently. Only in those cases whose atoms exist independently, the molecules will be the same as the elements, as the atoms of that element. Okay children? And this element is known as monoatomic element. This kind of element whose molecules are also the same as its atoms. So such elements are known as monoatomic. like helium. So helium is the example of monoatomic element. Is it, children? Now come to the question number 3. And the question is, write the formula of the following compounds showing the steps involved. Okay? And here the 4 different compounds are given whose formula you have to write. So the first one is sodium oxide. So children, please write the formula of sodium oxide, as it's made up of 2 different elements, sodium and oxygen, and the valency of oxygen is 2 and the valency of sodium is 1. So we can write the formula Na2O. Okay, so the formula of sodium oxide is Na2O. Okay, children. Now the second is magnesium nitrate. Magnesium nitrate. Okay, the symbol of magnesium is Mg, and the nitrate is a group, is it? And the formula of nitrate is NO3. Okay, children, and as you have learned, the valency of magnesium is 2 and the valency of nitrate is 1. So we can write it MgNO3 whole twice, because the valency of magnesium will move to the nitrate. So this is the formula of magnesium nitrate. Okay, now the next one is magnesium sulfate. As you know that the symbol of magnesium is Mg, and the symbol of sulfate group is SO4. Okay, and the valency of sulfate and magnesium, they both have the valency 2. So they both can simplify and we will write only MgSO4. Is it, children? And the fourth one is given aluminium chloride. Aluminium chloride. The form symbol of aluminium is Al and the chloride, that is Cl. Okay, valency of aluminium is 3, whereas the valency of chlorine is 1. So we will write AlCl3. So this will be the formula of aluminium chloride. Understood, children? So just once again I am going to repeat. Sodium oxide, its formula will be Na2O. Magnesium nitrate, its formula will be MgNO3 twice. Magnesium sulfate, its formula will be MgSO4, and aluminium chloride, its formula will be AlCl3. Okay, now come to the next question. Question number 4. What is a chemical equation? Why is it necessary to balance an equation? So children, you know that about chemical equation. What is it? Yes, a chemical equation shows the result of a chemical reaction in which the reactants and the products are represented by symbols or formulas. So it will termed as chemical equation. Okay, when a chemical reactions are represented by the symbols or formulas of reactants and products, so that time it will termed as equation. For example, this is iron, Fe, and plus sulfur. So they both are the reactants, and when these reactants are going to react together, we get the product, that is FeS, that is iron sulfide. So this representation of chemical reaction in which reactants and products are shown by their symbols or formulas are known as chemical equation. Okay, and it is necessary to balance an chemical equation because the number of each element should be the same on both sides of equation. Is it? In the last topic of the chapter, I have explained you about the balancing chemical equation. Why it is necessary? Because when we balance, then the equation will consider as correct. Otherwise, it will consider as incorrect. Understood, children? Now, just take an example of this balancing chemical equation. H2O. This is the formula of water. And when the H2O is going to break chemically, so they break into hydrogen and oxygen. But this time, this equation is not balanced. So it will consider as incorrect. Okay, because the number of atoms of elements are not equal in left side and right side. In left side, the hydrogen atoms are 2. Right side, hydrogen atoms are also 2. Oxygen atoms in left side 1 and right side it is 2. So that is why it will consider as not balanced. So we will balance it by okay. Now the hydrogen atoms in left side 4 and right side also 4. Oxygen atoms left side 2 and right side also 2. So this time this equation will termed as balanced equation and correct equation. Okay. Now come to the question number 5. And in question number 5 you have to balance the given equations. So the 4 equations are given here and you have to balance them. Okay, so come to one by one. The first one is given when magnesium reacts with sulfuric acid. The product we will get is magnesium sulfate and hydrogen. Okay, children? So, check that the number of atoms are equal in both the side or not. So, in left side, number of magnesium atom 1. In right side, magnesium atoms 1. Left side, hydrogen atoms 2. Right side, hydrogen atoms are also 2. Left side sulfur is 1. Right side sulfur is also 1. And left side oxygen atoms 4 and right side it's also 4. So we can say that all the elements are equal in both the sides. It means that this equation is already balanced equation. There is no need to balance it. Okay, now come to the second. In second equation, it's given that when calcium carbonate reacts with hydrochloric acid, the product we'll get is calcium chloride plus water and carbon dioxide. Okay, children. Now please find out the number of atoms, either it is balanced or not. So calcium in left side 1, in right side it's also 1. Carbon in left side 1, in right side also 1. Oxygen left side 3, right side it's 1 plus 2, 3. Hydrogen in left side 1 and right side it is 2. Okay, and chlorine in left side 1 and right side it's 2. it means that the equation is not balanced and it need to balance it. So simply for balancing it, if we write here two molecules of hydrochloric acid, so we will get the atoms of hydrogen in left side 2 and right side we already have 2 atoms of hydrogen, and left side chlorine atoms 2 and right side we also have the 2. Okay, so now this time our all atoms of elements are balanced. So it will consider as a now balanced equation. Okay, children. Now come to the next. Third, when calcium oxide reacts with water, it forms calcium hydroxide. Okay, now just check that it's balanced or not. So calcium in left side 1, in right side it's also 1 atom. Oxygen in left side 1 plus 1, 2 atoms, and in right side it's also 2 atoms. Hydrogen in left side 2 atoms and right side it also 2 atoms. It means that this equation is already balanced. And no need to balance it. Okay, now come to the fourth. The fourth equation is when silver is going to react with nitric acid. When silver reacts with nitric acid, it forms silver nitrate. This is silver nitrate plus water and plus nitrogen dioxide. So these are the products formed. Now check that it is balanced or not. So silver in left side 1, in right side it's also 1. Hydrogen in left side 1, in right side it's 2. Okay? Nitrogen in left side 1, in right side it's 1 plus 1, 2. And oxygen in left side 3, whereas in right side it's 3 plus 1, 4 plus 2, 6. Okay, children? So we need to balance it because it is not balanced. And for balancing them, if we write here the two molecules of nitric acid, so our number of hydrogen atoms will be 2 in left side and right side we already have the 2 hydrogen atoms. Nitrogen atoms will also be 2 in left side and right side we also have the 2 nitrogen atoms. Okay, and oxygen atoms will be 6. 3 2 are 6 and right side we already have 6. 3 plus 1 plus 2. Okay, so this time this equation is balanced equation. Understood, children? How to balance, is it? So these all are the balanced equation now. Now come to the next question. That is question number 6. Using the example of calcium chloride, explain how the formula of compounds are derived. And it's given that the valency of calcium is 2 and that of chlorine is 1. So simply by using the given hints that the valency of calcium is 2 and valency of chlorine is 1, we can say that the formula of a compound can be written if the symbols of its elements are radicals and their valencies are known. Okay, for example, calcium chloride. So as their valencies are given there in the question, so we can write that compound will form calcium chloride. Okay, and the elements in calcium chloride are calcium and chlorine, and the valency of calcium is 2 and the valency of chlorine is 1. Okay, so on the basis of given hints, that is the name of elements and the valency, we can frame the name of compounds. So we write them as calcium which have the valency 2 and chloride which have the valency 1. Okay, and there is no common factors in the valencies 2 and 1. So we will interchange them, and by interchanging the valency we can write it CaCl2. Okay, so the formula of calcium chloride will be CaCl2. Understood, children? Okay, so I hope that you understood all the answers of long. Now, after the long questions, we have the hot question. So you have to think about these questions and then answer them. So the question number 1 is, the symbol of an element is X. Please children, remember that. The symbol of an element is X, which is given in the question. Is it possible that the formula of the element will also be X? Is it possible? So explain with example. So what you can say, its formula is X only if it is a monoatomic element. Is it? It can be correct, it is possible, but in the case of only monoatomic elements, because you know that the monoatomic elements who's having only one atom. Okay, because the one molecule formed by using only one atom of this element. This is known as monoatomic. And according to the question, it is possible that X will be the formula also when it will be monoatomic. For example, helium, calcium, carbon, etc. So the helium, calcium, carbon, etc. These are the examples of monoatomic elements. Okay, children? Now, in case of elements that are not monoatomic, the formula is different. Is it? Because the one molecule will form more than one, so the formula gets changed. For example, nitrogen. So the one molecule of nitrogen formed by two atoms. So the formula will be N2. And the symbol of nitrogen is N, and the formula of nitrogen will be N2. Just like that, the phosphorus, the symbol is P, but the one molecule of phosphorus P4. Okay, so the number of atoms are more than one in these examples. So in this case, it is not possible that the formula will be the same. But in case of monoatomic elements, it is possible that the formula will be the same as their symbol, their atom. Okay? Now, the question number 2. Scientists can break atoms to get still smaller particles. In the light of what you have read in this chapter, do you think that a broken atom of say gold will have the same properties as an atom of gold? Is it children? Please think and then give the answer. As we know that the atoms can break to get still smaller particles. So, do you think that a broken atom of say gold will have the same property as an atom of gold? Yes or no? So the answer will be no. A broken atom of gold will not have the same properties as an atom of gold, because after breaking down of the atoms, the particles we will get will have the different properties. Okay. Now the question number 3 is, helium is the second most abundant element in the universe. However, there are no known compound of helium. Why? The reason, as we know that helium is a monoatomic element, is it? So it is the second most abundant element in the universe. But there are no any compounds on it. Means it's not going to form any compound while combining with other elements. So the reason is, in spite of being the second most abundant element in the universe, there are no known compound of helium because it is an unreactive element with zero valence. As its valency is zero, so it's not going to react with any other element, and when the no reaction will occur, so no compound will form. So this is the reason that, being the unreactive nature, there is no known compound of helium is okay. So this is all about your exercise of. Now children, I will provide you the PDF of these all answers and you have to complete the work in your notebook. Okay, and if you not understood the answer of any question, so you can ask it. Okay, now I'm going to start the next chapter. Today I will introduce the next chapter of your chemistry, and that chapter will be physical and chemical change. So this is our next chapter of chemistry, physical and chemical change. Okay children? Now as the name of the chapter is given, physical and chemical change, means that the changes which are going to occur in our surrounding, they may be categorized in two categories, that is physical change or chemical change. Okay, and these both changes have their different properties. Like a change is said to be physical or chemical, that depending on whether new substances are formed or not. If the new substances are formed, so such change will termed as chemical change. And if no any new substance are formed, so it will termed as physical change. Yes. So the physical change is in which a substance undergoes changes only in its physical properties, not in chemical properties, such as shape, size, color, and state. And no new substances are formed. For example, freezing of water, melting of wax, tearing of paper, and boiling of water to form steam. So in these all examples, what happened? No new substance are going to form. Okay, and some of these are reversible changes, whereas others are irreversible. So out of all physical changes, some of them are reversible, that can reverse back, and some are irreversible, that cannot reverse back. Okay, and a chemical change occurs when two substances react chemically to form new substances with different chemical properties. So the difference is there in chemical change, no new substance form, and in physical and in chemical change, new substance form. Is it? And a chemical change is also called a chemical reaction. Okay, children? So the original substances in chemical change participating are known as the reactants, and the new substance which are formed are known as products. Okay, so you can write that in a chemical change, which is also known as chemical reaction, the original substance are termed as reactants, and these reactants are going to form the new substances which are known as products. So this is possible only in change? Yes, chemical change. Or it is also known as chemical reaction. Okay? Now, during a chemical change, the molecules of the reactants undergo changes to form molecules of the products. As in previous chapter we have explained about the molecules, is it? So the same is going to used here when the chemical change is going to occur or chemical reaction is going to occur. Molecules of reactants undergo changes to form the molecules of products, because the molecules of reactants are different from molecules of products, and thus during a chemical reaction substances undergo chemical transformation to form new substances. And this is the reason during chemical reaction or chemical change what happens? Substances undergo chemical transformation. They get changed, they get transformed in their chemical properties and a new substance formed. Okay, and the chemical reactions that takes place around us all the time, like burning of fuel, cooking of food, rusting of iron, process of photosynthesis, digestion of food, etc. They all are the example of chemical reaction or chemical changes. Okay, because they all are the processes where chemical reactions takes place, and the reacting substances are different, are chemically transformed into the new products. Okay, like in the example of burning of fuel, when the fuel was not burned, it was in liquid state, and after burning it produces a new substance, that is heat, light, is it? Just like that, cooking of food, before cooking the food, they have the different properties, chemical properties, the different nutrients are there, but after cooking, their nutrients, their properties gets changed. Just like that, rusting of iron, before the rusting, their chemical properties are different, but after the rusting, the chemical properties gets changed. Okay. Now, the scientists study the properties of substances and the chemical reactions they undergo in laboratories. And this study of the properties of substances is used by scientists and technologists to improve the quality of substances and to make new useful substances. Okay, so new useful substances are going to make day by day, and this is only possible because the properties of substances, when we know, when the scientists know that properties of substance, and then the new substance are formed which have the new properties, which have the improved qualities. Okay, for example, a wide range of plastics and ceramics with very useful properties. The different kind of plastics we are using for different purpose. Okay, and they have been developed over the past few decades by different kind of chemical reactions. And the next example is the medicines, which are also made by a series of chemical reactions. And a study of rusting of iron has led to development of several methods of preventing rusting. So because of these all examples, we can say that the chemical reactions are very useful for us. Chemical changes are useful for us. Okay children? Now, thank you and have a nice day.